Good morning. Welcome back to week 2 of distance learning for Mr. Muller's 8th grade science class. Hope you guys had a wonderful weekend. We're going to talk about the agenda for today and for the rest of the week. And we're going to just talk a little bit about last week. And then we'll read the textbook and go over some PowerPoints. Okay. So if you remember last week real quick, we did a little check-in on Monday. Tuesday, we watched a TED Ed video, Would You Live on the Moon? A lot of wonderful answers there. I think personally I would not want to live on the moon just because I don't want to be away from my family and friends and from my students because, I love my job. So that would be quite difficult to go to the moon and be away from all that stuff and, have to worry about food and oxygen on a daily basis where I don't really have to worry about that here. But a lot of good answers from you guys. I'd say mostly no's, but there's some few yeses in there with some good answers. Wednesday, we talked about our vocab for chapter 1, Earth, Moon, and Sun. So we did a little vocab journal for that. A lot of you guys did a really wonderful job with that. Thursday, we started reading from the textbook, page 4 through 7, did a Google form worksheet. Friday, we watched 2 ed puzzles on constellations, and hopefully you did a little practice with your Quizlet, your vocab terms. Let's talk about today and then the rest of this week. So today is Monday, April 6th, obviously. We're going to read pages 8 through 9 in the textbook. I'm going to read that. You can read that on your own. So if you'd like to skip ahead when I get to that part on this video, you're more than welcome. And then there's a Google form questions answer. I apologize for this video getting in so late. I had planned for this video to get up at 7:30, uploaded like I always do. I don't know how many of you are watching these videos, but I try to get them up every single day and definitely before 9 o'clock. Although that's kind of when the daily distance learning agenda goes up. But I want to get them up by 7:30 because I know a lot of you guys watch them earlier. So I have made this video over and over again 15 times. I've had so many technical difficulties. I've had my son run in several times and I didn't want to keep those moments in. So I apologize. This is kind of the issues with distance online learning, and so just bear with me here. But today, again, we're going to read those pages and answer questions. Tomorrow, we're going to read pages 10 through 13. We'll have our first ever flip grid, probably about a minute and a half, possibly, where you submit videos and then I go through, check them, grade them, make sure you did the content. There'll be an ed puzzle as well tomorrow. Wednesday, we'll read pages 14 through 17. And then Tuesday, Wednesday, of course, I'll be reading as well. So if you'd like to just listen to me read those, you can. And then Wednesday, again, there'll be another Google form question to fill out. Thursday, okay, so I got another email immediately about some technical issues. So everything's going great this morning. Thursday, we'll have another flip grid and another ed puzzle. Okay, so let's move on. Let's read the textbook pages real quick here. Page 8. So if you're following along, go to page 8 in your textbook. The space needle there. You can skip ahead if you don't want to hear this. How do objects in the sky appear to move? Stars, planets, and other objects appear to move over time. They do move in space, but those actual motions in their apparent or visible motions may be very different. The apparent motion of objects in the sky depends on the motions of the Earth. So we actually, a long time ago, thought that Earth was the center of the universe and everything moved around us. But actually, we move in two ways. We rotate on our axis. Like if you put right through the middle of the top of the Earth, through the middle to the bottom of the Earth, you put a big spike. That's our axis. And we rotate it. So where our axis is actually tilted 23 and a half degrees. Okay, so the planet isn't like a regular, like you've seen globes, they're tilted a little bit sideways. And that's a that's a good model of how the Earth actually is, tilted sideways and then rotates. And then of course we revolve around the sun. So those are two reasons why we see movements of planets and stars and our star, our sun, in the sky because of our movement on Earth. Star motions. Stars generally appear to move from east to west. Okay, as Aryabhata thought this apparent motion is caused by Earth turning from west to east. The sun's apparent motion during the day is also caused by Earth's motion. Figure 3 shows this kind of apparent motion occurs. So this makes sense. So if you're thinking, if you're in my classroom, I'm lecturing to you, straight out of the window there is the east. Okay, and then behind me in the big parking lot is the west. So the sun looks like it rises in the east and sets in the west. But in actuality, the Earth is rotating, you know, once every 24 hours. So we actually are the ones moving from west to east, and looks like the sun, because it's sitting still, is rotating east to west. Okay, but it's actually us that is rotating. More changes. Seasonal changes. Constellations and star patterns remain the same year after year, but which ones you can see varies from season to season, and that makes sense. So the stars aren't going to move themselves. Stars will grow up, they will explode, die, really, and then they'll be reborn. Other stars will be reborn in other places, but stars don't move themselves. Okay, they're too big. They're the ones who bring all the planets and moons and stuff together to rotate around them because of their big size. They have all that inertia to bring in and force the gravity of these planets to move in and go around and revolve around them. So the stars aren't moving, but the stars move to us because we not only rotate, but go around the sun. So if you think about all the stars in the vastness of the universe, and here's our sun. If we're going around, we're going to see certain stars out here. And then when we're over here, we're going to see certain stars over here. Stars that won't change is like if you're in the southern hemisphere and you see star constellations below, or in the northern hemisphere, you see the North Star constellations above. Those ones aren't going to change, right? Figure 3. So if you look, no, we already did that one, right? No, sorry. Excuse me. Oh, no. For example, you can find Orion in the eastern sky in winter evenings, but by spring you'll see Orion in the west disappearing below the horizon shortly after sunset. These seasonal changes are caused by Earth's orbit around the sun. Each night, the position of most stars shifts slightly to the west. Soon, you no longer see stars once visible in the west, and other stars appear in the east. There are a few constellations that you can see all year long, like I talked about. Those are the ones closest to the North Star. As Earth rotates, these constellations never appear to rise or set. Page 9. Planets. Planets appear to move against the background of stars, as shown in Figure 4. So if you look, the orange dot there, week 1, week 3, week 5 is how it looks like the planet Mars is moving. And in week 7 and week 9, they're just going to be to the left of those. So week 7 is going to be a half inch to the left of week 5, and week 9 is going to be half an inch left to week 7. And that's just how it looks. Because the planets all orbit the sun in about the same plane, which means the same level. So think about you're in a building. Okay, and we're all on level 6 or we're all on level 4. That means we're on the same plane. Somebody's up in level 11 or level 3, they're on different planes. So the planets all look to be on the same plane as they revolve around the sun. They appear to move through a narrow band in the sky. The band is called the zodiac. It includes constellations such as Taurus, Leo, and Virgo. Some planets, when they are visible, can be seen all night long. Mars, Jupiter, and Saturn are all farther from the sun than Earth is. Sometimes Earth passes between them and the sun. When this occurs, the planets are visible after sunset once the sun's bright light no longer blocks the view. So that makes sense. If we are blocking the view of the sun from the planets that are beyond us, then we can see them a little bit better. They're still going to be, the sun's still going to, light's going to be reflecting off them, but we won't have the sun's light blinding us or being too bright to see them. Okay, so that helps if we're trying to see those planets far away. You can see Venus and Mercury only in the evening and morning. Venus and Mercury are, of course, the two planets that are closer to the sun than us. They're closer to the sun than Earth, so they always appear close to the sun. Venus is the brightest object in the night sky other than the moon, and that's because it's very close, and the sun is reflecting off that, so we see it as a bright light. Same with the moon. The moon is very close, and the sun is, when we see the moon at night, it's the sun's light reflecting off the surface of the moon, like illuminating it. It's not actually, there's no lights up there. It's not making its own light. It's the sun. Mercury appears low in the sky and is visible for a limited time around sunrise or sunset. Okay, that makes sense. During the day, those planets, we wouldn't be able to see them because the sun is right there and we're trying to look at the planet in the sun at the same time, too bright. So, if during the evening and during the morning, we can see those planets a little bit better. And you can see those fairly well. Okay, we're done with that. Let's move on to the first of 3 PowerPoints. And we're going to go through these really quickly. Some of them are going to be repetitive. I apologize for that, but I think it's important. The objective, actually, just for today, is describe how the Earth, Moon, Sun interact to show apparent changes in objects. It's going to just be about the Earth today. But as you can see, this is kind of the objective of the whole unit. Show apparent changes in objects, constellations, and moon phases. Earth, moon, and sun interact to show apparent changes in objects, constellations, and moon phases, which we'll talk about later. What can you see in the night sky? These are some of the big vocab words. Satellites, human-made satellites you can see, planets you can see, our planets in our solar system you can see. Some meteors, which are just big chunks of rock and ice that are floating through space. Comets, which have that wonderful, beautiful tail that burns up so you can kind of see them, big bright streaks across the sky occasionally. And then stars, which are just very similar to our sun. Some may be bigger, some may be younger, some might be really small, some may be on the verge of blowing up, some may be just born, so to speak. So the suns all around are just the stars that we're seeing. So last time I recorded this video, I clicked on this app and my computer crashed. So I'm not going to do that. And anytime I talk about apps or anything, you do not have to buy them and you do not have to download them. So I just want to make that very clear. There are some interesting, cool apps if you're, interested in seeing some planets or some constellations using a phone, possibly, to check them out in the night sky. Okay. First thing here we're talking about is meteors, which is sudden bright streak caused by the burning up of meteoroids in our atmosphere. Okay, so there's been some famous meteor strikes on Earth. Okay, we've seen the results of those. They think one of them helped, decimate and kill off the dinosaurs 65 million years ago. There's one in Russia in the early 1900s that, if you see the aftermath, it's quite amazing. And then there was another one in Russia, which, since they have a lot of dash cams in their cars in Russia, you can see the actual meteor streaking through the sky. Kind of looks like a missile coming in. And it kind of exploded before it hit and didn't do as much damage as it could have done. But most of the meteors you see are little tiny. You see those little streaks across the side. They're really small across the sky. I cannot talk this morning. And they're really small and they burn up really quickly. Okay? Comets. Cold mixture of dust and ice that orbits the sun. And you can see the famous tail of the comet here. Stars. Okay, that's basically what our sun is, right? It's a star, and it's very similar to other stars that you see out there. It's a giant ball of hot gas composed of hydrogen and helium. And you can see there's many different layers to the sun here. We're going to talk more about these layers in the coming weeks. What can you see in the night sky? Objects in the sky appear to move from west to east because Earth turns from from east to west because Earth turns from west to east. So we talked about that. What is constellations? How do you find them? They're a pattern or a group of stars that people have imagined to represent either a figure or an animal or an object, sometimes famous. Okay, and you can use a star chart to find the constellations. I'm going to talk about star chart real quick. If you go to the back of your textbook, page 164 to 165, there is a appendix A for star charts, and you can kind of see them. And we'll possibly do something with these, but you can see star charts in the northern and southern horizon in all the seasons: autumn, winter, spring, and summer. So you can see all the different ways they move. You can even see the Milky Way galaxy in that. It's really, really interesting. The Big Dipper. Okay, so that's famous. It's, supposedly, you should be able to see it all year long. So we're going to talk about that. I'm not going to spend too much time on this. The Little Dipper. Okay, so maybe you've heard of these, maybe seen these. There's Orion's belt. Okay, so you have his belt here. Here's the three of the belt. And he's got a shield and a sword. And he's standing in a pose, a warrior pose. Okay, let's move on quickly. I'm going to go through these slides pretty quickly because a lot of this is repetitive, but this is going to focus more on chapter 1. Oh, no. Yes, reload. Sorry. You guys are used to having technical difficulties in my class, so this should be no problem. Maybe I should pause the video. I'm getting better with this technology, but just bear with me here. Okay. Astronomy notes. Chapter 1.1, title, Sky from Earth Notes. This is pages 4 through 9 that we're reading. So you read 4 through 7. Today you read 8 through 9. Learning goals, I can describe the objects in the sky and how they move relative to Earth. So what can you see in the night sky? You can see the moon, stars, planets, meteors, and comets, like we talked about. What is a satellite? A satellite is any object that orbits a planet. So it's not necessarily a human made one. It can be. But when we talk about astronomy, when we talk about satellites, we talk about like moons of planets and rings of planets that orbit a planet. Okay, that's a satellite. What is a planet? It is an object that orbits the sun and has enough mass that becomes rounded by its gravity and has a clear orbital path. What I mean by clear orbital path is nothing is in its way. So it doesn't have another planet that interacts with it or is in its orbit. And this is one of the reasons why Pluto was downgraded to a dwarf planet, because it kind of goes in through other orbital paths of other planets and other things like that. But if it's cleared out its own orbital path, then it's going to be considered a planet, as long as it's big enough and it's rounded off by the effects of gravity. What is a meteor? Meteor is a bright streak of light produced by a small object entering atmosphere. We call those like shooting stars. Maybe you been outside and you saw a shooting star. What is a constellation? Pattern or group stars that people imagine to represent a figure, animal, or object. So we talked about that. How do objects in the sky appear to move? The apparent motion of objects in the sky depends on how Earth moves. That's the most important part of the chapter, is how all these things move around us in the night sky above or during the day. You just can't see them very well, is because of how the Earth rotates on its axis and revolves around the sun. And of course, the big thing here where you see different things is during the different seasons. So different constellations and star patterns may and do change from season to season because you're in different spots around the sun. What planets can we see in the sky? Well, we can see Mars, Jupiter, Saturn, Venus, and Mercury from Earth without a telescope. If you want to see the other 3 planets, you're going to need a telescope. Those are even farther out. Or other 2 planets, excuse me. Uranus and Neptune. Those are even farther out from Saturn, right? Okay, the next one, when we read, we'll do this. But we're going to move on to the last one here. Okay, I'm back. Observing the night sky, lab constellations. So these are the ones that are sort of the main ones that are visible all year long in the northern hemisphere for us. You can see the Big Dipper there. Okay, Ursa Major, considered the Big Bear up there. Okay, visible all year long. This one is visible fall/winter in the northern hemisphere. Okay, we've talked about this. This is Orion. Okay, you see Orion's belt again with the sword and shield and his legs. He's in a warrior pose. Sorry about that. Another technical difficulty there. This is visible in the winter months. We call this Gemini, or the twin stars right here. You can see. Okay, you can see they're kind of looks like they're holding hands. The twins, like they're dancing around. Okay, this is best seen in March. Okay, so you can probably see it pretty well right now, which is the Cancer. Okay, the constellation Cancer. So just a few constellations, went through the notes, read from the textbook. Make sure you do the Google form questions today. Tomorrow we'll do a flip grid and we'll read some more pages in the book and we'll do an ed puzzle. Wednesday, we'll read some more pages, do a Google form, and Thursday we'll have a flip grid and another ed puzzle to watch. So apologize for the long video here. Just kind of has to happen on a Monday, and with some of the technical difficulties, I apologize. But thanks for listening. We'll talk to you guys soon. Have a good rest of your day.